Okay, we're going to work on what's called a work problem. So I'll just read it. Working alone, it takes Ashley 7 hours to mop a warehouse. Julio can mop the same warehouse in 6 hours. How long would it take them if they work together? So what we're talking about is they have the same task or the same job. So I'll show you how to kind of set it up and how to think about that. So Ashley can complete the task or the job in 7 hours. Julio can complete the exact same task or job in 6 hours. But what they want to know, how long will it take if they're working together? Well, remember, together is another one of those English words that means addition. Some, all, together. Those are some keywords that would mean you're going to perform some addition. So let's go ahead and get started on that. So what we want to do is we want to add Ashley's time and Julio's time together to figure out, because we want to combine their time to see how long will it take them. So I'm just going to add 1 over h, and you could still write job to hours, plus 1 over 6, and together they're going to make they can do the one task in how many hours it'll take them to do it together. All right, so what do you remember about fractions? If you're adding fractions, they need to have the same denominator. So when you simplify that, we're going to multiply. All I did here is multiply, top and bottom here by 6, top and bottom here by 7. So that gives us 6 plus 7. And because they have the same denominator, 6 times 7 is 42, we can combine those things. So 6 plus 7 over 42 is equal to one task. And then furthermore, I just simplified, 13 over 42 is equal to 1 over x. However, the problem is we don't want x to be in the denominator. So how you've typically in the past learned how to simplify ratios like that is cross multiply. So you'd multiply this by both of these by x, those would cancel, and then you'd multiply both sides by 42. But another way to think about it, and you do both of those things because of equality properties, another way to think about it is when, let me go ahead and erase what I just did. All right, so when you have a ratio set equal to another ratio and the variables in the denominator, you can flip both sides. And what you do by doing that is you're implying that you just did all the work. You're implying that you did this and you did this, and then implying that you multiplied both sides by 42, and then those cancel. And then what you're left with is 13x equals 42, and then you divided both sides by 13. All of those are equality properties. And look what you're left with. Oops, I didn't mean to cancel that out. Look what you're left with. X is equal to 42 over 13. So I can save all of this work by, when you have two ratios with a variable in the denominator, you can just simply flip both sides, which is what I did here. Now that it's flipped, well, how much is 42? So what that's saying is you can do 42 jobs in 13, actually 42 hours, you can do 13 jobs because we flipped it. Well, we want to know how long it takes them together to do one job. So you're just going to have to simplify one more time. And you do that by just simply dividing 42 divide by 13. And they completed that one task when they worked together. Now, this is assuming that they kept the exact same pace as when they were working alone. So when they worked alone, that was their rate. 1 job in 7 hours, 1 job in 6 hours. If they kept that exact same pace and they worked together, then it would take them 3.2 hours to do the 1 job. All right, that's it for the work problems.